In this AstroPictionary concept video, we want to go through types of close binaries. What do we mean by the word close in a binary? Well, close in a binary is where a system that has more than one object appears as one object in the sky. We know that there's more than one object present, but in our image, such as this one from Aladdin at Sinbad, we see only one object in the sky. But let's say we study this object, we observe it over a period of time, and we may see that it wobbles in the sky, or we'll take spectra of the object and we see that the spectra indicate a radial velocity or a wobbling, and that would indicate another object is present. So we infer the second object to be there or a third object to be there, such as in the example of W Uma, which is W Ursa Majoris. There are three major types of binaries that are close. The first one is a detached binary, where we see both stars. The second one is a semi-detached binary. And the third one is a contact binary. Let's first by looking at the detached binary. In the detached binary, such as these two neutron stars, they're completely separate. And an example of a detached binary would be Cirrus A and Cirrus B. Cirrus A is the large one, and Cirrus B is the nearby one. We see two separate stars. So each star has its own what's called its Roche lobe. And it's basically its gravitational boundary. When these two stars come close enough, their Roche lobes become teardrop shaped. If these two objects are further apart from each other, then the Roche lobe would be a circle around the star. When the two objects come close together, the Roche lobe stretches into this teardrop shape. And when they come and they connect, they're close enough that they have a connection. We call this the inner Lagrange point, or Lagrange point 1. Generally, one star will be more massive than the other star. In this particular example, we're going to select this smaller star to be the more massive one, and that's called the primary. And it usually has a mass, and we just give it 1, M1. It's the primary M1 star. The other one is the secondary star, and we just give it a mass M2. In this particular example, we're looking at a mass ratio Q, which is always going to be defined in our work as the mass of the secondary divided by the mass of the primary. And we're looking at a ratio of 0.3. So we're looking at the secondary star as being 1/3 the mass of the primary star. All examples that I show here, the detached, the semi-detached, and the contact, all have Q equal to 0.3. Now the difference between the detached and the semi-detached is that the semi-detached secondary star has filled its Roche lobe. So remember, the Roche lobe is kind of like its gravitational boundary. Now its weakest point is going to be this neck. And so it acts like a balloon. That's a filled balloon, and it's going to lose its mass through the neck. And generally, there'll be material that'll be dropping in, forming an accretion disk around this primary star. In this contact binary, we have our secondary star that's completely in contact with the primary star. And one example of this type of system is W Uma. Let's look at examples of each one of these types of systems. Let's start with the detached system, which we showed as Cirrus A and Cirrus B. Now, as you can see with Cirrus A and Cirrus B, it looks pretty round. So we have a circle around Cirrus A, we have a circle around Cirrus B, and they are pretty much separated, and their Roche lobes are pretty circular. If we take a look at this example of two neutron stars, notice that we have one of them, the more massive one, that's going to be your primary, is pretty round, but your secondary star has this more of an oval shape. So it's already started to kind of try and fill in its Roche lobe, and it's getting that teardrop shape to it. So there's an example of a close binary. That's a detached. Let's go take a look at another example. In this case, we're going to look at the semi-detached. In the semi-detached case, remember I said the secondary filled its Roche lobe. It's losing its mass through the neck of its balloon type shape, and it's going to form the secretion disk around the primary. Well, that's an example that is shown here. Here we have sometimes it's called the donor. Your donor is also just going to be known as your secondary star. It's donating its material to the primary star, which in this case is a white dwarf. I put a little dot there in the center to indicate where the white dwarf is located, but in general, you're not going to see it because you have this material that's coming in. It goes over the disk and under the edge of the disk, and then it slowly spirals in and it's going to land in on that primary star. So generally, the disk is so wide, you don't see the small compact star in the center in the case of a white dwarf or a neutron star or a black hole star. Now let's take a look at an example of a type of semi-detached. This one is an algol, and it's a computer simulation. As you can see, we have this teardrop shape of our secondary star, and our primary star here still has this more round shape, but it definitely is a semi-detached close binary system with the point in between being the inner Lagrange point. Now let's take a look at the last example, and that last example is going to be a full contact system where we don't really have this neck. It's kind of going to be a blurry neck, and we have a simulation of that, and that one is W UMA. So we have, once again, both of them seem to have this teardrop shape, but we don't have a contact point. So it's going to have both are going to be in this teardrop shape, and they're sharing material back and forth. And this is what is a full contact system, and this one is known as W UMA. These are examples of types of close binaries.